Alright, here's another example for our regular polygons and trig. So what we have here is we have a side length of 20. That's kind of nice for us because we can right away find what the perimeter is, but we're kind of missing our apothem at this point. First, 1, 2, 3, 4, 5. We have a regular pentagon here. With our regular pentagon, we have our side length. P is equal to n times s. N being the 5-sided figure, s being 20. P is equal to 5 times 20. P is equal to 100 units. So we're halfway there for this already, since we are given a regular pentagon. Our next order of operation is we need to figure out the central angle. Our central angle is equal to 360 divided by n, n being the pentagon. And I'll even highlight that. So we have 360 divided by 20, get 18. Or, why did I choose 20? Divided by 5, that's my fault. 360 divided by 5 gets you 72 degrees. For our central angle to be formed, we need 2 radii. So we draw our center. So here our central angle is 72 degrees. And if we were to draw an apothem, it's an angle perpendicular bisector. Half of 72 would get us 36. So this would be 36 degrees. So here the only thing we need is our apothem. So what I'm going to do is I'm just going to focus on this part. I'm going to redraw it. So if that was 20, this will become 10. We draw right 36 degrees, since these are two complementary angles. 360 minus, or 90 minus 36 would get you 54 degrees. And our goal right now is to find this apothem to figure out what is the area of this regular polygon. So, the way we could do that is we're given this side length. Sine's the easiest one to kind of work with this one, I think. Or tangent, I mean. We have two things given. We're not going to use our radius here. So tangent's the only one that would work. Depends on what angle you want to choose. Again, some old hippie caught another hippie tripping over apples. I know right away we're not going to use sine or cosine again because we don't need that hypotenuse. So the only thing we're going to use is that tangent. So what we're going to do is the tan. What degree do I want to use? We can use 54 degrees. So the tan of 54 degrees, since I did 54 degrees, we look at the opposite. Our opposite we don't know, we'll call it x. And then our adjacent, which is 10. So from here, x over 10. What we're going to do is we're going to do the inverse operation. Tan of 54 degrees is equal to x over 10. Multiply both sides by 10. This will cancel. You get 10 times the tan of 54 degrees is equal to x. And just to find this apothem, ooh, that's confusing. Let's see. We don't want that to be our x. I was just saying that this is where our x is. That looked confusing. We don't want to use the hypotenuse, was the point there. Alright, back on track. So what we have here is 54 tan times 10. That gets us about 13.8. So now we know our apothem. We're good to go. I'm going to make this our space we're going to finish our work in. So now that we have all this, we have our perimeter. Area is equal to 1/2 the apothem times the perimeter, which is equal to 1/2 the 13.8 times 100. So you do 0.5 times 13.8 times 100. You get this is equal to 690 units squared. All right, there you go.